Hi everyone, welcome to today's Australian Water School webinar on MAR for Utilities, presented by Greg Ingleton of SA Water. It's good to see you all here today. My name is Trevor Pillar, National Partnerships Manager at iSwarm, and we are going to be in for a really interesting time, I think. Before we start, can I just see whose hands are raised, who's with us today, and whether you're using the icons okay? If you raise your hand, I see those hands. That will mean that we can find out whether you're working with the Zoom webinar software or not. And if you want to ask a question, and we really would love you to do that, or make a comment, just press the Q&A and then write your question. And all I can say is write them early and write them often. That will be great. All right. One other thing I'd like to say is that our webinar series has quite a lot in it. I won't read through all those, but I'd really encourage you to come on board and join us for these free webinars as they come up on Thursdays. We look forward to having you at those. But look, today's agenda is like this. We're going to do 25 minutes presentation by Greg. Then we're going to do 25 minutes open to everyone, free for all, just about, not quite. But ask your questions. So there's a lot of time available later on after Greg's presented to talk about the issues. Then we'll be recording this and sending it out to everybody after the webinar's over. But at the end of the webinar, when you close off, you'll get automatically a screen comes up that asks you to tick some boxes basically, but it helps us shape the future webinars. It's very, very useful to us in that respect. Today's attendees come from all over the globe. There's people from China and India, Calcutta, I see University of Calcutta, and Germany, and most Australian states. All right, let's get right into it. Greg, we're so glad to have you today. Greg's a Business Development Manager for Environmental Opportunities at SA Water. He's worked with SA Water for over 14 years in numbers of roles. I won't read it all out, but suffice it to say that he studied environmental science, but also worked on the ground in several agribusiness areas. I think that's really useful to have a person who's done both sides of the coin, theory and practice. Greg's main role is to explore commercial opportunities for SA Water. So we are really looking forward to hearing from you today, Greg. And can I just say once again to everyone, start writing your questions. We want to see them livening up the debate and discussion after Greg's finished. But for now, it's right over to you, Greg.
Yes, hi everyone. Thanks, Trevor, for the introduction. As Trevor said, my name's Greg Ingleton. I work at SA Water, and today I'm talking about managed aquifer recharge for a water utility and why we would have managed aquifer recharge in our water portfolio. So the outline of the presentation today is I'll just give a quick overview of alternative water in Adelaide and some of the MAR schemes that we're operating currently and how that looks across the landscape of the Adelaide Plains. And if time permits, I'll jump into a couple of quick case studies about the alternative use of alternative water, and I'll explain what that is in the next slide. So water in Adelaide, sometimes we have it, sometimes we don't, sometimes we have too much, and often we don't have enough. Some of the terminology that I'll be using throughout this presentation is MAR, or Managed Aquifer Recharge, is just the process of getting water into the aquifer. Aquifer Storage and Recovery, or ASR, is the type of MAR that we do, and that is taking water, injected it into an existing bore, into your target aquifer, and then drawing that back out again when you need it. Recycled water, we call treated effluent recycled water. So that's the water that's treated at a wastewater treatment plant, and then the product of that is recycled water. Stormwater, we don't call recycled water. Stormwater is basically urban runoff, and it's a standalone product. But when you combine the two together, we call that alternative water. So what do we have in Adelaide? We have fairly low rainfall, majority of which falls in the winter months and a little bit in spring, and we have fairly high evaporation. And we have the two do not coincide. So we've got plenty of water when our evaporation rate is low, and not much natural water when it's high. Hence the requirement to store the winter water if we want to use it in summer. What we also have in Adelaide is a great aquifer storage system. We have great aquifers within Adelaide. You can see here from the schematic that there's a number of aquifers below the ground. It's a fairly stable landscape, the Adelaide Plains. These aquifers have been formed naturally over tens of millions of years. And around Adelaide, we have 50 aquifer storage schemes. The majority of this, or 49 of them, are stormwater schemes, and we have one recycled water scheme, which I'll talk to you about shortly. The capacity of those 50 schemes is about 18 gigalitres of water. That means we can store 18 gigalitres of water in the aquifer through those schemes and use that 18 gigalitres when it's needed. As I said, mainly stormwater at present. And the schematic down here is just a visual of the Adelaide Airport stormwater scheme that we have, where we're storing water in the tertiary 2 aquifer, a confined aquifer. And then we take the water out, and we're currently doing a trial with that water, which I'll talk about at the end of this presentation. So recycle water and stormwater, the future, as I see it. And again, this is just potential future, I suppose I should say. It's not SA Water's view that this will happen, but this is just an example of one of the things that we're looking at. So we have around 50 gigalitres of recycled water available, which, if not used, goes out to sea. And we have 50 gigalitres of stormwater available. Again, if it's not harvested and used, then it goes out to sea. And with those systems, we have, with the existing recycled water and stormwater systems that we have in place, there's a lot of pipe work already in the ground. Now, the blue dots on that schematic represent the stormwater schemes that are sprinkled around Adelaide, and the black and yellow symbols coming onto the screen now represent the large wastewater treatment plants that SA Water operate along the Adelaide metropolitan coastline. The interesting part of their location and the locations of the existing stormwater schemes is that it wouldn't take much of an effort to actually connect them all up to the recycled water scheme. So what you'd have then is a climate-independent alternative water source by mixing the stormwater and the recycled water together. Plus, you'd have a reduction in your salinity, which sometimes is an issue for uses of your recycled water. So the sum is greater than the parts, basically. We've worked it out that to do this would take very little pipe work. We're talking a few kilometres of pipe work to actually connect all of these schemes up to recycled water schemes. There's governance issues, there's things that we'd have to work through about the ownership of the water, but by doing this, you actually can guarantee supply to customers, which is something that's sort of holding back the expansion of stormwater schemes at the moment. And the other thing that we could do with this is purely irrigate 20,000 hectares of land across Adelaide. So here's a bit of an aerial photo of Adelaide, and this is what 20,000 hectares of irrigation would look like across the Adelaide metropolitan area. Now, this is not what's going to happen because there's plenty of houses and things in those areas, but it's just a graphical demonstration of what could actually be achieved with that level of reuse. So just wanted to talk about recycled water and how we view it in SA Water. So basically it has three end uses. One of them is a discharge. We get rid of it through large outfall channels. The second is that we use it for environmental purposes or livability, such as irrigation of the parklands, public open space. And we have also looked at, and we have developed, the use of recycled water for economic development, food production, as is evident in McLaren Vale and Bolivar with the large primary production up there and down there. So this is a picture of the wastewater treatment plant reuse scheme at Aldinga, where we're growing lucerne with excess water. So it's a way that we can actually utilise the excess water that we have on our land to produce a crop, which then produces revenue. Most wastewater treatment plants, we don't have a single end use. We have a combination of 2 or 3 of those of the above. The issue is there that if you have a wet year, you still will probably need to discharge some, even in treatment plants where you have what we call 100% reuse. You'll still need to discharge in those wet years. storage is the key. The only way that you can actually use this water to its ultimate volume is with storage. So I just wanted to then talk about one of the schemes that we have and the reasons why we actually put this scheme in place. So this is the story of the Aldinga Managed Aquifer Recharge Scheme. The water comes from Christie's Beach Wastewater Treatment Scheme, which is about 10 kilometres or so north of Aldinga. There's Aldinga down the bottom there. The reason why we take the water from Christie's Beach down to Aldinga is that it has a lower salinity. So you can see on the graph here that the average salinity is around about 700 milligrams per litre from Christie's Beach, and it's up to about 1100 to 1200 for Aldinga. We do have an increase in salinity when the water is put into the aquifer. So that's important that we don't bring water down, use water that is already marginal as far as salinity goes. So some of the drivers why we put this MAR scheme in is that, as you can see from that schematic there, on a daily basis, we just didn't have enough water from Christie's Beach and from the Aldinga Wastewater Treatment Plant to supply the demand for the vineyards around McLaren Vale. So yeah, a real driver there. We just couldn't meet demand on that daily basis. We had to have storage to close that gap. We know that in the winter we have more wastewater available, more recycled water available. It goes up just through infiltration into the network. So you get a sort of a 20 to 30% increase in the water that you have available, but nobody wants to use it at that time of the year, hence the need to do the storage. Some of the benefits, and this is, I suppose this is just a way to represent the benefits of an MAR scheme as opposed to a normal standard surface lagoon. So what you'll see here is this is an aerial view of the Aldinga Wastewater Treatment Plant, and we have a 700 megalitre lagoon down the bottom here. And at that site, we also have the MAR scheme, which currently is 400 megalitres. So we have 4 bores. We have the ability to put 400 megalitres of recycled water into the aquifer in winter and draw that out in summer. You probably can't see it, but that tiny little spot there on that image is the footprint of one of the bores. So as I said, we have 4 of those. If we wanted to increase it to a 700 megalitre aquifer storage scheme, we would just need to put in some more bores, which is quite a simple thing to do. The purpose of this graphic, I suppose, is really to show you, though, what that means as far as a footprint goes. So that little blue spot within the lagoon is the size of the footprint to store 700 megalitres in the aquifer as opposed to on the surface. And what that means for us is that this piece of land down here is worth about $1 million. As you can see on the paddocks either side, we're growing lucerne there and producing revenue. If we wanted to expand the MAR by another 300 or 400 megalitres, it's as simple as putting extra bores in. Once you put your lagoon storage in, that's the size of your storage. You can't actually step that up any further without building another storage. So that's another one of the beauties of having a recycled water MAR. The other thing is you don't get algal blooms like you do in surface storages, and you don't get evaporative losses. But you do, in some cases, particularly where you have a groundwater that has a higher salinity than the water that you're putting into the ground, you do have an increase in salinity toward the end of your extraction. So this here shows the injection period, and that's I suppose the treated recycled water, and this is the extraction period as that water is coming out of the aquifer. And you can see the nitrogen it drops fairly significantly, as does the phosphorus. So that's the phosphorus red line going through there. But as I mentioned, one of the issues is that you do get an increase in salinity. This graph was about the recycled water quality about 3 years ago. That's actually now improved, and it's really just toward the end that we start to see that increase in salinity occurring. So what does this mean for the area? I suppose it means 500,000 bottles of wine, which is, you can't argue with that. That's about a bottle per family per year that comes directly from the recycled water MAR at Aldinga. So, a great contribution to the productivity in that area and to revenue within the state. I just wanted to flip over now to what we're calling the Northern Adelaide Irrigation Scheme, or NAIS. It's a project which has been announced by the government, penned in federal funding, of course, as most things are, where we're looking to use an extra 20 gigalitres of recycled water on the Northern Adelaide plains to stimulate further food production, including high intensive glass houses and also your broad acre vegetable production. It would be a large investment by government and private sector, and with the full implementation of that 20 gigalitre scheme, we'd be looking at storing 12 of those gigalitres in a recycled water MAR scheme. Now, we're at the stage where this is a potential. We can have 12 gigalitres of storage on the surface, or we could have that in an aquifer storage system. We're still just working through which way to go with that. I personally would prefer to see it in the ground, and then we can keep that land on the surface productive and used for more production. Currently, we send 20 gigalitres of water up to the Northern Adelaide plains, and there's a mix of glass houses and your sort of open field type vegetable production, and it brings in about $400 million worth of revenue into the state per year, so it's fairly significant. The NAIS scheme would actually double that, but because there is a focus on high-tech glass houses, the number of jobs and the productivity and revenue increase associated with that is well in excess of the 400 million that we're currently seeing from the 20 gigalitres that we have there available now. So in doing that, in looking at where we're going to start to store this water, there are some barriers. One of the bigger barriers is that there are a lot of private bores on the Northern Adelaide plains. Historically, that was the source of water, was the groundwater. Due to increases in salinity and a reduction in the sustainable removal of water from the aquifer, the 20 gigalitres of recycled water was sent up there previously for Virginia, so that was in the 1990s, and a lot of private bores around, which can cause some issues. What we looked at, this was a couple of years ago, we looked at putting in a scheme around this area here, and we talked to the community up there. They weren't very happy about it. They saw that there was a risk that this recycled water could actually make its way to their private bores. They use that, some of them use that for showering and for crop production, and they were just a bit concerned about that. What we found out was that with modelling, it would take about 200 years for that water to move off the site that we were going to be using, and a bit longer then to actually reach any private bores nearby. But that still didn't appease the community, so we went through a fairly extensive community consultation process where they helped us to develop some guidelines to enable us to do this into the future without having impacts on their way of life. One of the interesting things, though, is that we do know that when you start to do MAR schemes, because you're pushing water into the aquifer, you do get an increase in pressure. So whilst the water takes hundreds of years to move away from the site, the actual water itself, the pressure doesn't. It happens within days, and you could turn an area. So this is modelling of putting 1 gigalitre of water into these 3 bores here. You'd have artesian conditions in this blue shaded area, which means that if there are any bores in that area that are not capped, or the integrity of the bore casing is not up to scratch, then you may actually get water coming to the surface or water going through into some of the other aquifers. So that's not great. You'll have a zone of pressure around. So one of the challenges that we're finding now is that there's proposed conditions in the EPA licenses which says that if you do put an MAR scheme in, then you're responsible for those bores that may actually be impacted by that. 1,700 bores out there can be quite an expensive exercise, so we're just working through that now with the regulators as to how we actually go about addressing that issue. Now, I'm running out of time, I think. I've got a few minutes, so I'll just whiz through just some of the alternative uses of alternative water. And
Still got 5 minutes, Greg. You're okay. You're doing well.
excellent.
Still got 5 minutes. Yep.
Thank you. So this is one of the schemes, one of the trials, I suppose, which has come about because we're able to store this water in the aquifer. So the idea came to me once flying back from Melbourne over to Adelaide, looking out the window, everything's brown. You know, most times of the year, the whole country is brown, basically. Flying into Adelaide Airport, same situation. We had a nice big brown airport, adjacent to which we have a recycled water pipeline, which takes recycled water into the city, and a stormwater aquifer storage scheme, both of which are underutilised and have a fair bit of capacity, right next to a 400 odd hectare site. So we thought, well, how can we put the two together and come up with a great outcome? So we pitched it to the airport directors. They agreed to do a trial on the basis that we would green the place up and we would cool the air, and the benefits that could come from that. So we set up the system, the trial. The little stars are the weather stations that we have around the site. So you've got the wind coming from this direction. So you have upwind. This is the irrigation area in the blue rectangle. And then we have downwind sensors as well, so we can see how persistent that cool air is as it heads away from the irrigation site. These are just a couple of photos taken at the same spot a few months apart, and you just add water and you get green. And what we found also was that, so we realised that we could, it's obvious, you put water on the ground and it goes green. So we knew that we'd be able to tick that off as one of the benefits from it. But what we also were interested in is, can we cool the air down to a point where it would have a difference, a significant difference to the operation of the airport? And so these 4 stars here represent weather stations, which are on the graph down here. So you can see on this particular day, the upwind temperature was getting up to 37 degrees, and within the irrigation area it was around about 34 degrees. So we measured a 3-degree temperature difference on that particular day. The average that we were finding over the whole trial was 2.4 degrees for the entire summer period, but the majority of the days above 3-degree temperature difference were hotter days. So this is the difference between the air within the irrigation area compared to the air outside of the irrigation area. And you can see that the schematic there is just using all of the data from the weather stations to see where the cool air was. If we were to expand this to the entire airport site, some of the benefits that we've identified is reduced air temperature, which means a reduction in energy use in the cooling towers, reduction in fuel takeoff, fuel usage in the aircraft as they're taken off because the air is cooler and denser, which is something that they could have put into Phoenix last week and been able to continue flying, but they had to cancel 50 flights because they didn't actually add water. That's all they had to do. Reduce bird risk, reduce discharge to the sea from SA Water because the water is actually being used. Revenue from the sale of the crops. So we've identified that we can actually grow crops here instead of just putting grass down and watering the grass. We can actually grow crops, and we've been successfully growing lucerne for the last year, which then provides revenue, which then can be passed back to buy the water, and you'll have cooling of the adjacent residents. So it really demonstrates a circular economy, I suppose. The other, and just quickly, the other one is Adelaide Parklands. This is where we've identified with Flinders University, or was actually led by Flinders University, that we could start to cool the city down by irrigating the parklands that surround the city. We put some transects of weather stations in. This was the trial site down here at Veal Gardens, and basically they were looking at how much temperature difference we could make to the air within the city. So the trial site down here, you can see that the air cools down quite significantly, but it doesn't persist into the city. And that the issue there is that you need to have trees or some sort of green infrastructure to funnel that cooler air into the built environment. Otherwise, it just gets swamped by the heat within. Then we started to think, okay, well, could you do this on a neighbourhood basis? So this is probably our next step, is to look at irrigation of parks around an urban area, and whether you could actually get some localised cooling that could occur from that. And it just adds to the importance of green open space. Not only does it provide physical and social and mental benefits, mental health benefits, but it can also cool the environment. And this is, optimistic as Adelaide current summer state, not at the moment. And this is what it could be in the future if we were to use our water a bit more wisely, our alternative water, and realise the benefits that we can get from that. Can we be cool Adelaide? That's the question. And the other thing is, I should mention that we're currently doing an economic assessment to look at what the benefits are at the airport, and the numbers that are coming out are quite significant. So we're identifying now that there are some real economic benefits in actually using this water for these particular purposes. And that's all. Thank you.
Greg, that is outstanding. If I had known a long time ago that to get cool, all I need to do is add water, I would have been made, I reckon. That was really good. And it's not just that; it's the economic benefits. All power to SA Water for having a thinker in residence like yourself, and I really appreciate that rundown of where MAR can be used for in utilities and in cities. On the screen right now, you can see there's a raised hand. If you wanted to come on screen and have a chat, just raise your hand and we'll uplift you, and then you'll get a face on screen and a voice on screen. That'd be great. If not, just write your Q&A questions. That's also just as good. And there's a couple there now. We'll get started in a second. I just wanted to say thanks very much to the people from India and Germany. I can't imagine what time it is over there, Jana. But thanks for joining us. And G in China, and Pravan in Udaipur, in the Maharana Pratap University of Agriculture and Technology. It's a lot of people from quite a long way away. It's great to see you with us. Thanks very much. All right, let's get underway. Helen from the Water Corp in WA, and I should say there's about 1, 2, 3, 4, 5, 6, 7 or 8 states represented around Australia today. But Helen asked the question, is the water going into a confined aquifer, and what depth, Greg?
Yes, sure. So for the scheme down at Aldinga, it is going into a confined aquifer. All of our schemes so far have been into confined aquifers. At Aldinga, we're going to the tertiary 2 aquifer, which is around about 50 to 70 metres below the ground surface. We're also using that aquifer for the stormwater scheme at the Adelaide airport, but at the airport it's about 180 metres below the surface, so the aquifer is actually tilted a little bit. We are investigating currently a similar aquifer storage system down in the southeast of South Australia in an unconfined aquifer, which I suppose would have repercussions or interest, I suppose, from a water corp's perspective. So whilst they are confined aquifers now, that's the easy ones, I suppose, to be injecting into. There is some work going on about using unconfined aquifers as well.
Yep, that sounds great. We've got a group from Sydney Water joined us, but their question on as a written question is, with the urban parkland trials, what were the challenges of overcoming any water quality health criteria? With the urban parkland trials, you get the question. Yeah.
Sure. Yep. So the water is, we have tertiary treated recycled water, which is suitable for irrigation. Then we have to put it through a membrane. So we've got ultrafiltration and then ultraviolet, and then it goes into the parklands for irrigation. So the main restrictions that we have on that is that it can only be irrigated at night to minimise the contact with the public. We do have a fairly, it's treated, very well treated water. All of the information that we've got to date, all the data shows that we don't have any pathogen risks within that, but we're still conscious of making sure that we're only irrigating, or the council is only irrigating at night. Any leaks or any pooling are addressed immediately. There was some concern about salinity and the nutrients, so there's been a fair bit of work going about just tracking where the salinity goes, making sure that it's not being accumulated in the soil profile. And the nutrient one is an interesting one. What we found is that a lot of the greenkeepers or greenskeepers that work in Adelaide City Council didn't realise the nutrient content of the water was such that they didn't have to fertilise. So they're now addressing their fertiliser regime to take that into account, which then is a fairly significant saving for them as well in their fertiliser use.
So it's a clear economic benefit, which you may not have thought about pre the operation. Yep. Well, we'll move straight along. We've got 15 minutes, but we'll keep these questions rolling on, I think. Another question, some info on energy requirement for the bores. What sort of level of energy requirement?
We have got some numbers. I can't recall them off the top of my head, but it's something in the realms of, it must be a kilowatt per megalitre. No, that can't be right. I'll give you some numbers. It's about 20 cents per kilolitre to take it out of the ground. It's putting it into the ground is a lot cheaper. In some bores you don't need much pressure to actually inject it into the ground. But at Aldinga, we're using the pressure that's coming from the transfer from Christie's Beach down to Aldinga as the injection pressure, so we don't actually have to add any pressure to that to get it into the ground. But yeah, getting it out of the ground is around about 20 cents per kilolitre.
Yep. And if people want to go further with this, I just want to say that are you contactable, Greg, on some of these issues? Maybe there's a paper about energy we could send out after this webinar. We're going to send an email to everyone pointing to this recording and all. But we could also send some PDFs or some documents that might back up.
Yeah, I don't know if we've made that public at the moment.
Sure,
I think it's because the numbers vary depending on your aquifer properties, your depths to the aquifer, that sort of thing. Yep.
No, sounds good. John, welcome, Dr. John Radcliffe. We'd really appreciate a question from yourself, so I'll hand right over to you, John.
I was very pleased to hear Greg talking about the economics of these various projects towards the end of it. Now, I had some involvement in the funding of the Regional Parkland Scheme. We had a lot of concern about the overall economics, particularly the capital. What can Greg tell us about the ability to service the capital invested that's necessary to do the MAR schemes, but all the irrigation infrastructure and everything else that needs to go with it? Are you picking that up in your economic evaluations? Thank you.
Yes, we are. So, yeah, thanks, John. The interesting part about the Parkland Scheme is that it wasn't built on an economic basis. It was built as a reaction to the drought and because of public concern, making sure that we save that iconic parklands area. What we are doing is for the MAR schemes is that we compare them with a surface storage. So we want to compare apples with apples, looking at the same size surface storage as to the Aquifer Storage. We can actually then work out which one has the best economic outcome. What we try and do, it's an interesting question about whether the price, and I think this is where you're going, whether the price of the water includes the capital investment within that price. Yes. Often it doesn't, because there's also a cost to that being discharged to the sea. So what we have to consider there is what the cost is to actually treat that water, and what the cost is to discharge that water, and the environmental cost, but also then what is the economic benefit, not just to SA Water, but to the state for that production. So if you looked at it purely from SA Water's perspective, the numbers may not add up completely, but then if you take into consideration the environmental impacts of the discharge, plus the production within the state for food and jobs and growth, the more holistic picture actually gives you a better economic outcome.
Thank you.
Sounds good. Yep. All right. Thank you, John. Appreciate your coming on screen and asking that question. That's excellent. All right, we'll press on. Simon Roberts, and Simon's from E2 Design Lab in Melbourne. Are there any schemes or studies that consider use of stored alternative water for third pipe into homes and businesses, or even indirect potable substitution?
I'll just answer the indirect potable substitution one first. So within South Australia, there's a mandate, or a political mandate, that we won't do indirect potable reuse. My personal view on that is that that's exactly right. My concern is that you've got this water source that's full of nutrient, full of all the trace elements that are great for crops. Why would you treat that to then, to drinking water quality, which only 1% of it will be drank anyway, and the rest will be going in showers and on your garden. So my personal view is that you use your recycled water for its best purpose, which is irrigation. So that's that question. But the storage of the water, yes, we do. The Aldinga MAR scheme supplies water both to the vineyards, but also there is part of that that goes off to get treated a little further and then go into third pipe systems for green open space, and also for household use, for laundries, toilets, and outdoor use in the home. So the one issue I suppose I should raise is when you're looking at it from an economic perspective, third pipe systems are quite expensive, fairly intensive infrastructure, versus your agriculture and low water use per area of land, versus your agricultural use, which is a lot less infrastructure and a lot greater use, a lot more volume can be used.
Yep, no, that sounds good. Praveen from India is a PhD research scholar, and he has asked, can we use MIS for irrigating crops? Now, I've got the acronym MIS in my head. I don't know whether you got that, Greg.
No. If you're asking about MAR,
I think so. Yeah, I think so. Yeah.
Yes.
MAR,
yeah, definitely.
Crops,
yeah. That's the purpose of it. Is to store
sure,
it. Yep.
Yep, no worries. The next one is from Lakpar in University of Calcutta. Will MAR schemes help in hilly terrain conditions?
It depends on the aquifer. Generally, if it is hilly, the aquifer has probably fractured. It's probably a little bit. It's not flat like our aquifers. It's actually sort of up. But there are aquifer storage schemes that occur at the foothills within Adelaide. So yes, if you know your aquifer well enough, and even if it is a fractured rock aquifer, then you can store water in it. But the most important thing is that you have to know your aquifer. You have to know the characteristics. You have to know where the water is going to go when you put it in. You don't want to be pumping water into the ground and then losing it. It runs off down a fissure or down a crack somewhere and disappears. That's just not going to make economic sense. So you really need to know the characteristics of your aquifer before you proceed down this path.
So you're talking about the geology, the slope?
Absolutely.
All aspects.
Yeah. So it's really the underlying geology which dictates whether you can do aquifer storage or not.
Yep. Well, we're up to about our last question now. This one's from Dr. Peter Dillon. Hi, Greg. Have you considered relative advantages of storing stormwater and recycled water blended or separately in aquifers, considering salinity, other water quality parameters, and the quantity of water recovered and the value of the uses? Might pay, Greg, just to flick on that Q&A question. It's a fairly long question, but it's actually really quite a insightful question and delves into a few things. So did you get that? Have you considered relative advantages of storing stormwater and recycled water blended separately? Yep, considering salinity, quality parameters, and quantity of water recovered and the value for the uses. Yep.
Yes. So I suppose there's a few parts to this question, and the one is that in an aquifer where the native groundwater has a significantly higher salinity than the water that we're putting into the ground, one of the things that we've looked at is whether you could put the stormwater in first to create a freshwater interface, I suppose, then put your recycled water in, and that reduces the volume of water of your recycled water, that's interfacing with the native groundwater. So what you'll find then is that as you take the water out, your recycled water, you could take out up to 100% of your recycled water without having that increase in salinity, by using that stormwater that you injected first as sacrificial water. We've also, in my view, that's probably the best way to be using the two in an aquifer that's saline. Blending together before you put it into the aquifer is another way that you can do it, but you may have that increase in salinity for your first five or 8 cycles. Once these systems start to mature, like I said before, that increase in salinity towards the end of your extraction, it tapers off quite well. Yeah.
Really good.
Yeah.
So, well, look, we've come to the end of the questions now. If there's any more comments, Greg, we'll move on to the end of the webinar and close off. But you're okay with that then? But thanks very much for all the effort to this, and it's been really wonderful hearing the case study from Adelaide Airport, but seeing what's happening down in Aldinga and other parts around South Australia, indeed Australia. Thanks for being with us today, everyone. It's been absolutely delightful to have you all together. The feedback will come up when you close this window. I do want to say that we'll be sending out to everyone the recording link and also a copy of Greg's PowerPoint in a secure PDF. So stand by for that, and then look out for these coming free webinars. The one in the middle there by Dr. John Williams, I think, is going to be a real winner. Have we continued water reform in Australia? It's a really good issue to be discussing. So look out for that Dr. John Williams, but also the others that are there. Thank you very much for joining us today. I'll look forward to seeing you again next time you come to a webinar. Yep. Bye.